All right. I won't take too long because we'll want to get right into the digital work. But if we go to the next slide, today we're talking about the what people would know as the Barangaroo boat, found in 2018 during the archaeological works for Sydney Metro. We found this 30-foot boat. So there was a lot of work gone into the excavation. And if you want to go more into that, just Google it and you'll find it. But yeah, but a lot of the work that was done on there was one thing was we did on-site photogrammetry. So Guy Hazel and Brian Shanahan did that, and that was great to get the boat in situ, which then we could use that to then put in CAD and then reconstruct the lines and finish the boat, so to speak. But also once it went into the conservation after excavation, if we go to the next slide, thanks, Michael. Silent World Foundation took the conservation phase and they were able to 3D scan every single individual timber. So that way you could get a good understanding of the condition of each timber post-excavation and pre-conservation, as well as produce the standard 2D drawings. And then also we did a rescan after conservation in which we could see what changes happened during conservation, because this was the first time we've done Australian timbers in at this scale. So what happens in conservation phase, the changes. So you can see the overlay down the bottom, the hatched one. You see there was about up to 7% shrinkage from excavation to post-conservation and slight changes in the shape. So it was very minimal, which was good. But so that's a bit of a background. But now Michael will go on to what more digital work can be done.
Thanks, Ben. Yeah, so I've touched this project a few times over its life, not right from the beginning, but engaged at it now. So this is the base timeline that it was discovered 7 years ago, excavated, and that in situ photogrammetry done. Conservation process started in 2019 and didn't finish till 2024. So there was a 5 year process of curing, and it ended up with the dried timbers. Most items got scanned with an Artec EVA, structured light scanning, in 2020. I actually went in and did a few select items in 2022 with both an Artec Spider and photogrammetry, which we'll go through. And then 2024, as Ben said, post-conservation, so once they were dry, a smaller subset was rescanned with an Artec EVA. And then this year, we've been doing a full data audit. So this created a lot of data. So, going through that, and then obviously creating 3D print files and creating an online library. So the site scans I'll start off with, they were done on 15 key days. So there was a lot of site scans done between September and December 2018. So it took about 2.5 months from discovery to get it out of the ground. You can see on the right the kind of clouds that were being done. So a lot of groundwork handheld is this sort of bottom row, and then the pole cam that you can see bottom right is doing these ones that look like they're up in the air. But that was done while the work was going on. So a lot of the time there were people there working, parts of it were covered, there was a lot of water in different places, and thankfully they all had georeferenced data, so they were being done with proper geolocation. And you can see a few pink spray paints on this one right in the middle if you look closely, but they weren't the same, because rocks were moving, so the georeferenced data was close enough to line it up later. But the main purpose was these orthos, as you see in the middle. So they were doing it to create ortho mosaics, to document the site, to then be able to do drawings from and things like that. But the 3D reconstructions were actually not great. They were done at the time, this was 7 years ago, so they were done in medium quality. They were using the dense cloud method in Metashape. It was quite ordinary at the time for doing ortho outputs. But I remember Ben asked me to clean one up, and he gave me one of the scans, and I spent 5 hours on it just making it printable. At that stage, we actually went, can we just get the data and reprocess them? So this legacy data now, the window of 7 years. And we reprocessed all of those this year at ultra high quality with depth map. And the change was astounding. So you can sort of see the top one, especially pay attention to the top right, where there's this little noise everywhere and double shadowing of objects, down to fully clean. Same data, same alignment, just a different processing method 7 years later. So we then had that, and we then had all the different scans. So we could line them up we could then, that's a closer view of, from the first day, as the timbers came off one by one, we had this great reference set to be able to look at that, but we could then 3D print them. So we created 4 blocks, all exactly the same dimensions, exactly aligned to each other, that we 3D printed at a sort of modest 30 centimetre size that I think Ben has sitting on his desk, and they'll be used for reference as the modelling happens now, because it's a really good map in situ of where all the timbers were at the different layers, the different strata as they were taken off. So that was one. The second part was dealing with the Artex scans. Like I said, there was a lot of data. In 2020, they did 242 individual scans, EVA scans. In 2022, I did 5, and 2024, there was 75 done. So that's a huge amount of data, terabytes of data. So I started a data audit this year. I was sort of engaged for that purpose to start to go through them. This sort of shows a little bit of my tracking methodology, where we went through all the numbers. We matched this across to other databases that we had, including the type. The scale was quite an interesting one to pull, that we then used on printability, which I'll come back to later. Like, would it fit on a printer? Did I have to cut it in half or 3 bits? I did some scoring originally, and then went through them one by one, opening them, going through the workflow to create intermediates, fix the textures, create publish files, create print files, and then print them. So this was really quite a big process to go through this year to audit the data. This is what I did. This is what I built. It's kind of crazy in itself, but so these were so old in Artec, they were a different file format. So they were SProj that Artec dropped a few years ago now. So I had to open them. We're sort of bottom left to start with, convert them to a new A3D format, which is the new Artec format. At that stage, I'd reprocess them if required. I'd orient them and export them again into intermediates. Clean up the textures in Photoshop. Thankfully, they were all done very standard texture levels in Artec, but Artec usually has a bit of a color shift and a bit of a darker texture, so I fixed that with a few scripts. I actually used Agisoft, even though this wasn't photogrammetry. Agisoft is just really good at decimation and baking. It's just a really good, easy tool to do that. So I actually used Agisoft to then start to generate those deliveries from that, from that, obviously exported the masters that went onto the pedestal library that I'll show you in a minute, but also creating a print master. So I cleaned all those in Mesh Mixer, cleaning stray geometry, fixing holes, also removing tags. There were a lot of tags that were put on the timbers that if we tried to put them back together with the model, those tags would get in the way. And I remember Ben telling me he was going to Dremel them off. I'm like, no, we'll just cut them off digitally. So we ended up with that. And then we ended up with a bunch of STL files in binary that we printed using Bamboo Studio. And the Bamboo printers, wow, they're just amazing. So, slicing them there. Ben Johnson I worked with, who I think's here listening as well. We did some great work and printed them in PLA using both the H2D and an X1C, and finally saving that print file out. So a lot of work going through that audit, and this is the end result. So we ended up with a full library in pedestal of every single individual timber as sort of a catalogue, so that you could go and look at them quickly, easily measure them, do all of that. And then we also ended up with a second collection in pedestal of all the different site scans. So these are unlisted right now, so we're not publishing them yet, but at some stage they will get published. And then obviously we had all this stuff, so we created a couple ensembles in pedestal using the ensemble tool. So I'll just play a couple of videos here. This is the site scans in an ensemble, because they were georeferenced. We could line them up. So, and if you could line them up, you can now, I remember an early archaeologist telling me you can't undig a site. But now you can. You can dig it, you can undig it, you can look at the different examples, all georeferenced, and in browser. So you can really use this as a reference as well to now, as we reconstruct it, as we go through that. And you see, as I go down here, I've got all the different days. You can go between and see all the different bits that were taken off in different orders. That's actually quite wild as a tool now to help in the next steps. But this will also help with interpretation, and we can use this in the gallery, and we can use this on the web, and we can use this to help tell the story. So that was sort of the output of reprocessing those site scans that I think was absolutely worth it when you look at that result. The next one is this, and this is just trying to show off, really. So I loaded every single timber into an ensemble, which is really sort of testing the limit of pedestal. But this has got 240 objects as independent objects loaded in browser that you can now come here and manipulate them individually, turn them individually. We're not really using this to put it back together. It's not really built for that. But again, it's great as a sort of visual catalogue of every single timber that was done. And you see all these little yellow tags. We left the tags on for this one. So, the print files didn't have the tags, whereas this was very much a close representation of what they were like when they were in the water. And quite interestingly, these were the scans of when they were wet. So, before the shrinkage that Ben spoke about. And then finally, not finally, the printing endeavour. So we worked out pretty quickly, rather than going to industrial printing, let's just bang it out on domestic printers. It was going to be easier and probably better quality just to cut it in half and glue it than trying to get some kind of large 1 metre printer. So we got some bamboos, and you can see the top right there, sort of the way we laid them into quite a big build volume to get some of these prints off. And this screen just shows you then some of the different slicing and different orientations of what we did, and numbering them all up, bagging them, delivering them. So this is what we ended up doing. It took about 3 months. That's every timber at 1 to 5. That Ben now has the best Lego puzzle piece project in the world to try and put this back together as to what it is. But at the same time, both Rampe Realistic Imaging and the museum bought the same printer. So we both bought an H2D. They'd just been released when we started this. So to make sure that we've got redundancy now, so that the museum actually has capability to print their own stuff ongoing and adapt as the work progresses, or if Ben accidentally breaks one, he can just reprint one. So that's really good capability building. The final bit is this little thing I did in 2022, which I dug up recently. So this was a little experiment we did at the time on some of the smaller timbers that have been missed. We wanted to see, it had all been done with Artec Eva, great. What about a spider, or what about photogrammetry? So I went out for a day when it was being cured and did that test. So the end result, generally speaking, photogrammetry's on the left, Artec's on the right. They're not that indistinguishable. Colour, big deal. Like I shot these cross-polarised. The colour's wildly different. So that's one of the dead eyes. This one, again, photogrammetry on the left, colour wins, but also this one, the sharpness of the card, that because it was very thin, the spider was sort of missing corners of that. But the mesh itself is not that pretty indistinguishable, really. Like the two are on par, just a bit sharper on colour, a bit softer on colour, and a bit less on accuracy of colour. There's some finer ones, and you can see there's a lot of noise in the spider ones that I've cleaned in the photogrammetry ones. But generally speaking, photogrammetry won on terms of colour. There's no surprise. Should be no surprise to anyone here. Dealing with structured light, probably a tie on mesh if I was really going to call it. Some in one way, some the other way, but generally a tie. But spider's a lot quicker. Eva's a lot quicker. Trying to do photogrammetry of those original 242 timbers at the scale would have been prohibitive. And also scale is given. And this is a really important job for scale. So, using the Eva originally was the right choice over photogrammetry because scale is given and because it's quicker. We didn't have to worry about calibrating all of that, or they didn't have to at the time. I didn't do those original ones. But that's a sort of a good analysis to then look at now as we think about moving into the next phases. So the results, we have an online library. Like I said, that's important because they're before they were cured. So, it's how it did go together once. So we now have to look at warping and how Ben does and how he deals with that. We 3D printed a full set and have capability to, not just reprint, but also print jigs and rigs as Ben puts that together. And most importantly, we have a fully audited data set that's archive ready. So that will go on the shelf now. Everything's everything's similar files, similar mastered objects, detailed audit trail on all those notes that I took against each one, which will actually go into the actual set of the data that goes along with this find. I think, Ben, you can probably talk about the next steps.
Yeah, we'll just do a bit of a conclusion. And so the next kind of year looking ahead is reconstructing this 1:5 scale physical model, which we can use for further interpretation aid in potential future reconstruction of the vessel itself, which would be great. Still to give news about the future of that in due course, but at the moment it's mostly analysis and research and using these brilliant 1:5 scale prints. They're absolutely brilliant. So thank you everyone, and thank you Michael as well for all the hard work and that you can see that it's been done.
Bunch of people to thank. I mean, this isn't everyone involved in the project, just in the digital bits. Obviously there was a whole cast of thousands involved, and these are the sort of key companies and partners that went through. So